Welcome to the Copperfield Electric Podcast. Today, we're taking a deep dive into a question many of you electric vehicle owners, or maybe soon to be owner, are probably asking yourselves. How much power does a home EV charger really need? We've sifted through quite a bit of information to bring you the clearest, most practical insights, basically giving you the shortcut to being truly well informed on this pretty essential topic. Now, before we jump right in, just a quick word about where we've gathered our insights for, this particular deep dive. A lot of our expert understanding comes directly from the folks at Copperfield Electric. They're your trusted 24-hour electrician right here in Orange County. They're a family-owned business really dedicated to top-quality electrical services all across Southern California. They serve areas like Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, Laguna Beach, Mission Viejo, basically all the surrounding communities too. And they specialize in a whole range of services, including the very EV charger installations we're discussing today, but also panel upgrades, home safety outlets, and they have 24/7 emergency services. So yeah, they really live and breathe this stuff. Okay, so our mission today, pretty simple actually. We want to demystify the power requirements for home EV charging, help you understand what's truly important from, well, an electrician's perspective, and equip you with the knowledge to make smart, safe decisions for your electric vehicle.
Yeah, and what's really fascinating here is that this idea of power for an EV charger, it isn't just some simple number you pull off a label, not at all. It's actually more of a dynamic interplay. You got your car's battery, your daily driving habits, and this is crucial, your home's entire electrical setup all playing a part. So we're going to break down how kilowatts, charging levels, and even your circuit breaker, how they all factor into getting you charged up safely and efficiently. Okay, let's unpack this puzzle piece by piece.
All right, let's start with what often feels like the absolute basics, but I know it can get confusing fast. When we talk about how much power an EV charger needs, what exactly are we measuring, and how do the different charging levels factor into that equation? For someone new to EVs, it can feel like a lot of jargon.
That's a great place to start, definitely, because it's where a lot of people get, tripped up. Think of it this way. When we talk about kilowatts, or kW, we're really talking about the rate of power. It's how fast the energy is flowing from your home into your car. So the higher the kW, the quicker your car charges. Pretty straightforward.
Okay, rate of flow, got it.
Right. But then you have kilowatt hours, or kilowatt. That measures the total amount of energy your car's battery actually stores. It's kind of like the size of your car's fuel tank, if you want an analogy.
Oh, okay, so capacity.
Exactly,
Yeah.
capacity. So a bigger tank, more kilowatt, just naturally takes longer to fill, even if you have a fast pump, a high kilowatt-hour charger.
That makes a lot of sense. Speed versus capacity,
Yeah.
speed and size. Now, I know there are different levels of charging, level 1, level 2, and it feels like there's usually a clear winner for home use. Can you walk us through those levels and maybe explain why one typically rises to the top for most homeowners?
Absolutely.
Yeah.
There are really three main levels people talk about, and they represent quite a spectrum of charging speeds and capabilities. First, you've got the level 1 EV charger. This is the most basic, and honestly, you probably already have access to it. It uses a standard 120-volt outlet, just that regular wall socket you plug lamps or your phone charger into.
Okay, the everyday outlet.
Exactly. But it's definitely the slowest option. We're talking maybe adding only about 3 to 5 miles of range per hour, which is fine if you drive very little or you just need an occasional top-up overnight, maybe on the weekend. But for most daily drivers, relying on level 1 would be like trying to fill a swimming pool with a garden hose. It works eventually, but it's just not practical for consistent everyday use.
Right, yeah, that paints a picture. Very slow.
Then you step up to the level 2 EV charger. And this is really where home charging shines. It's the most common and definitely the most widely recommended for residential installation. Level 2 uses a 240-volt outlet.
Okay, like the ones for big appliances?
Precisely. Just like what powers your electric clothes dryer or your oven. This significantly boosts the power delivery. You're now looking at anywhere from, say, 20 to 30 miles of range per hour added, sometimes even more with higher amperage setups. This kind of speed makes it perfectly practical to just plug in when you get home, and you wake up to a fully charged battery every morning.
That sounds like the sweet spot for most people.
It really is for home use. And then finally, you have the DC fast charger. These are the big guns, the ones you usually see at public charging stations, often along highways for road trips. They offer extremely rapid charging because they use direct current, DC, and have massive power outputs.
But not really for home, right?
Almost never. We rarely see these installed at homes, and for very good reason. They're incredibly expensive, Both to buy the unit and the installation is complex. Plus, they demand an enormous amount of power from your home's electrical system, often needing something closer to a commercial-grade electrical service. They're simply overkill for residential use, like bringing a fire truck to fill a teacup.
Yeah, definitely overkill. So, okay, for the vast majority of homes, it sounds like a level 2 charger really hits that ideal balance. It's fast enough to be convenient for daily use, but not so powerful that it becomes impractical or wildly expensive. That's a really crucial insight, I think, for anyone listening who's contemplating their own setup.
Exactly. It's about finding that practical, effective solution.
So with those charging levels clarified, let's talk about the practical side. How long does it actually take to fully charge your EV at home? I know that's not a static number, and it depends quite a bit on the car's battery size, right?
You're absolutely right. It's definitely not a one-size-fits-all answer. The time it takes is directly influenced by both factors: the size of your EV's battery, measured in kilowatt-hour, and the power output of your charger in kilowatt-hour. So imagine you have maybe a smaller electric car with, let's say, a 40 kilowatt-hour battery.
Okay.
That might comfortably recharge completely overnight, maybe in, say, 4 to 6 hours, using a pretty standard level 2 charger. But if you own a larger EV, perhaps a performance model or an SUV with a 75 kilowatt-hour battery.
Which are becoming more common.
They are. With that larger battery, you could be looking at maybe 8 to 10 hours with that same level 2 charger to get a full charge from empty. And this difference is exactly why many people opt for a slightly higher powered level 2 charger at home. It just gives them that confidence, that assurance that they'll wake up to a full battery even if they drove a lot the day before or have one of these larger capacity vehicles.
Okay, so it really is a balancing act. You've got the charger speed, your car's battery size, and then how much you actually drive day to day. But what about the home itself? This is where I think a lot of people start to get a bit nervous, thinking about their electrical panel. What should we be thinking about when it comes to our home's existing electrical infrastructure? Can it handle it?
That nervousness is completely understandable, and frankly, it's healthy, because this is a critical safety component. Before any charger installation, it's absolutely non-negotiable to ensure your home's circuit breaker and the entire electrical panel can safely handle the extra electrical load.
Right, you don't want to overload things.
It's exactly. Most level 2 home EV chargers require a dedicated 240-volt circuit. And dedicated means it needs its own breaker in your panel, separate from everything else, much like your electric oven or maybe your central air conditioning unit probably has. This prevents overloading other circuits in your home when the charger is running.
So how do you know if your main service is enough? You hear numbers like 100 amp, 200 amp.
That's the key question. Think of your home's main electrical service like a highway, bringing power into your house. A 200 amp service, which is pretty common in many modern or recently updated homes, is like a robust multi-lane highway. Usually that's more than capable of handling all your regular household appliances, plus a typical level 2 EV charger simultaneously, without any issues.
Okay, 200 amps is often good.
Often, yes. However, if you have an older home, maybe it only has a 100 amp service, that's a smaller road, or even with 200 amps. If you have a lot of other high-demand electrical equipment, maybe multiple large AC units, a big electric hot tub, or a workshop full of power tools.
Things that draw a lot of power.
Exactly. You might be pushing the limits of that 200 amp service. In those cases, an electrical panel upgrade might be necessary for safe, reliable, and consistent home EV charging. It's not just about avoiding tripped breakers. It's fundamentally about ensuring electrical safety for your home and family.
That makes sense. And how many amps are we typically looking at just for the charger itself? Because that seems to be the number that often comes up when people talk about installing one.
You're right. Amps for the charger circuit are a key part of the conversation. Most level 2 home EV chargers require a circuit that provides somewhere between 30 and 50 amps of current. The specific amperage depends on the charger model you choose, and, indirectly, the size of your car's battery, essentially, how fast you want it to charge.
So more amps means faster charging.
Generally, yes. A charger that needs a 30-amp circuit, for instance, operating on that 240-volt circuit, provides about 7.2 kilowatts kilowatt of charging power. If you go for a faster option needing, say, a 50-amp circuit, that translates to a more robust 12 kilowatts of power. This direct link between the amps of the circuit and the kilowatts of charging power is how your charger's physical requirement translates directly into charging speed.
Okay.
So getting that amperage right for your needs and your home's capacity is crucial. And it's definitely a detail where, talking with a licensed electrician is invaluable. They can help you figure out the perfect setup.
Okay, so we've covered the different charging levels, how they interact with battery size, the importance of voltage, and the crucial role your home's electrical system, the panel, the service amps, the circuit amps plays. Given all this information, how does someone actually go about choosing the right charger for their specific needs? What key factors should you, the listener, really be weighing when making this decision?
Yeah, bringing it all together, when selecting your EV charging equipment, we really encourage people to think about three interconnected factors. These really synthesize everything we've discussed. Number one, your driving habits. First, you need to honestly assess how much you drive each day. Do you have a short daily commute where maybe even a slightly slower level 2 charge might suffice overnight? Or do you frequently take longer trips or just drive more miles daily, requiring more rapid and consistent charging to ensure your car is always ready to go? Okay, how much you drive makes sense. Number two, your EV's battery size. As we've really highlighted, the size of your EV's battery, its kilowatt-hour capacity, is paramount. Larger batteries fundamentally need more power, meaning higher kilowatt output from the charger, to charge in a reasonable amount of time overnight. Choosing an underpowered charger for a large battery, well, it can lead to a lot of frustration with slow charging times.
Right. Don't want to wake up to a half-charged car.
Exactly. And number three, your home's electrical capacity. And this is the reality check. You absolutely must know what your home's electrical system can actually support safely. Can your current panel and wiring handle a higher output charger? Maybe one needing a 40 or 50 amp circuit? Or will you need an upgrade to your main panel, or maybe just run a new dedicated circuit? This is where that professional assessment we talked about is truly vital before you buy anything.
So balancing those three things you're driving, the car's battery, and what your house can handle, what does that usually translate to for the average EV owner? Is there a kind of sweet spot power output that generally works best for most people at home?
Yes, absolutely there is. For the vast majority of EV owners, a level 2 charger with an output somewhere in the range of 7.2 kilowatts up to about 11 kilowatts is often the ideal target for home use. Now remember, 7.2 kilowatt typically corresponds to a 30 amp circuit, and 11 kilowatts might be around a 48 or 50 amp circuit, depending on the specific charger.
Okay, 7 to 11 kilowatt.
Right. That range strikes an excellent balance. It provides sufficient charging speed to comfortably top up most EV batteries overnight, even the larger ones we're seeing now, while also being a practical choice that generally aligns well with the electrical capacity of many homes without requiring massive, expensive upgrades. And the installation costs are usually reasonable in this range. It truly is that optimal middle ground for daily convenience and long-term satisfaction.
And the benefits of getting this whole equation right, the power level, the installation, they seem pretty significant. It goes far beyond just getting your car charged, doesn't it?
Oh, absolutely. That's a crucial point. A properly planned, professionally installed, and correctly powered charger provides a whole range of invaluable advantages. First, obviously, you'll experience much faster charging times compared to trying to rely on those sluggish standard household outlets. This just makes daily EV ownership incredibly more convenient, less of a chore. Second, it ensures reliable charging every single time. You eliminate that constant background worry about overloading your home's electrical system or dealing with annoying tripped breakers in the middle of the night.
Peace of mind there.
Huge peace of mind. Third, you gain the ultimate flexibility to charge overnight whenever it suits you, meaning you wake up with a full battery ready for whatever your day holds without ever having to detour to a public charging station unless you're on a long trip.
Convenience factor is big.
Very big. Fourth, it offers compatibility with virtually all modern electric vehicles sold today. The connectors are standardized now, so your investment in a good level 2 charger is pretty future-proof as EV technology continues to evolve.
Good point.
And finally, and this is critical, through professional installation, it guarantees improved safety and optimal performance. You get that invaluable peace of mind knowing your system is installed correctly, meets all electrical codes, and is operating efficiently and safely for years to come.
Now, on the flip side of those benefits, let's talk about the things to avoid. What are some common mistakes you see people make when they're trying to set up their home EV charging? It sounds like there are probably plenty of potential pitfalls.
You've hit on a really critical point there. Unfortunately, yes, we frequently see several common mistakes that can lead to safety issues, unreliable performance, or just a plain frustrating charging experience. One really significant error is using an existing outlet that simply isn't rated to handle the continuous high amount of power an EV charger draws for hours on end. Even if it's a 240-volt outlet, say for a dryer you don't use often, it might not be suitable for the constant load of an EV. This can cause the outlet to overheat, potentially damage your wiring, or in the worst cases, pose a serious fire hazard.
Wow, okay, that's serious.
It is. Another major oversight is ignoring your home's overall circuit breaker capacity, the main service we discussed. If your panel is already pretty close to its limit with your existing appliances, adding a high-demand EV charger without checking can lead to frequently tripping the main breaker, causing inconvenient power outages and potentially stressing your entire electrical system over time.
Just annoying and potentially damaging.
Can be. Many people also make the mistake of choosing an underpowered charger for a large EV battery. They might try to save a little money up front by getting a lower amperage charger, maybe a 16 or 24 amp model, but then they quickly realize they're stuck with painfully slow charging times, especially if they have a long daily commute or a big battery. It just leads to constant frustration.
Yeah, penny wise, pound foolish, maybe.
Could be. And perhaps the most critical pitfall we see is people skipping a professional EV charger installer. Trying to do a DIY installation if you're not a qualified electrician, or hiring an unlicensed handyman who might not know the specific codes and requirements for EV charging. Well, that can cause significant safety issues. They might not adhere to current electrical codes, they might not properly assess the home's infrastructure first, or ensure the correct grounding and wiring techniques are used. The risks are just too high.
So this really, really drives home the point about getting a professional installation. It's clearly not just about getting it done quickly or conveniently. It's profoundly about safety and ensuring the long-term reliability for such a significant electrical addition to your home.
Precisely. Professional installation is absolutely foundational to both safety and performance. It's not an area to cut corners. When you work with licensed, bonded, and insured electricians like the team at Copperfield Electric, who are also background checked, which adds another layer of trust, you get a thorough expert assessment. They'll meticulously check your electrical panel, they'll perform load calculations to confirm your home can safely handle the required power draw. And then they'll expertly set up the new dedicated circuit, install the charger itself, and ensure everything meets or exceeds current electrical codes and safety standards. This expert service is absolutely key to avoiding those dangerous risks we just discussed. It saves you time, prevents future headaches, and ultimately lets you enjoy complete peace of mind with your home EV charging system for years.
Okay, so to really bring it all together then, when you ask that initial question, how much power does a home EV charger really need? The answer for most homes, for most people, points squarely towards installing a level 2 EV charger, and specifically one with an output somewhere in that 7 to 11 kilowatt range. That setup seems to effectively balance the charging speed you need, the cost involved, and what your home's existing electrical capacity can likely handle.
That's a perfect summary. And if we connect this to the bigger picture, think beyond just your current EV. It's really about planning ahead a little bit. Many EV owners, they find themselves upgrading their vehicles over time as new models come out with bigger batteries or faster charging capabilities.
Right.
Or maybe the household adds a second electric vehicle down the road.
Right, that's happening more and more.
It is. So choosing the right power setup, now maybe opting for wiring that can handle a slightly higher amperage charger than you currently need, like putting in wire rated for 50 amps, even if you start with a 30 or 40 amp charger, means you likely won't be faced with another costly and time-consuming electrical upgrade later on. This kind of forward-looking approach can really future-proof your home charging infrastructure, saving you money and hassle in the long run.
That's really smart advice. So a well-planned and professionally installed home EV charging system isn't just, a utility or an appliance. It's actually a smart investment in your daily convenience and the safety of your home and in the long-term enjoyment and usability of your electric vehicle ownership.
Couldn't have said it better myself. It really enhances the whole EV experience.
And just a reminder for our listeners in Southern California, for reliable and affordable electrical services, especially if you're considering an EV charger installation, Copperfield Electric proudly serves Orange County and the surrounding areas. That includes places like Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, Laguna Beach, and Mission Viejo. The professional team offers 24/7 emergency services as well, and they're always ready to help you schedule a professional EV charger installation or just provide a detailed quote if you're still exploring options. Well, thank you for joining us on this deep dive today. We really hope you feel much more informed and confident about figuring out your own home EV charging needs. Now, what aspect of EV ownership will you optimize next with this newfound knowledge?